Okay, so today we're going to start the process of finding limits, hopefully without a picture sketch and hopefully without a table of values, the direct evaluation stuff. So first and foremost, here's a typical function, 5x squared. We know it's just a parabola, so there's nothing tricky about it. So direct evaluation should work. You just plug it in and you get 5 times 9, 45, and that's your limit. Pretty straightforward. Again, this is a line, so nothing, quirky about a line. You just directly evaluate. -1 plus 3 is just 2. This is also just a flat horizontal line. So as you're approaching an x of 8 and you plug in 8, you're just going to get 2. And here the limit as x approaches 4. This is just a line. So you plug in a 4 and you get 4. So nothing too tricky there. The properties down at the bottom I'm going to bypass for now because honestly they're not used all that much, and without being there I'm just going to get right to the skills for the sake of time. So on this one, directly evaluating creates an issue. So if directly evaluating is not going to work and there's something quirky going on, you need to manipulate. Now the manipulation here is in the form of factoring the numerator and then canceling. And so even though we get a hole in the graph there, now once you've reduced and manipulated, now retry directly evaluating, and you now can directly evaluate without getting an undefined. See, initially if we had plugged in a 2, we would have gotten 0 over 0, which is known as the indeterminate case. And so if we plug in a 2, we get 2 plus 2 is 4, and that's our limit for that question. The second exercise is much the same. We're going to try factoring first. Actually, we would try plugging in -1 first. That's going to give us on the bottom 1 minus 2 plus 2. So it'd give us something over 0. Plug in -1, it would be -1 plus 2 minus 1. So it would give us 0 over 0. So the indeterminate case again, so it requires manipulation, which is going to come in the form of factoring. So if you pull out an x, we're left with x squared plus 2x plus 1. On the denominator, we would group, take out an x. Oh, is that a squared or a 3? I think it's a 3. So I take out an x cubed, be left with x plus 1. Take out a 2, and you're left with an x plus 1. So your numerator can be factored more. That's just x plus 1 times x plus 1. And your denominator grouping can be fixed x cubed plus 2 with an x plus 1. So what we get here is the ability to cancel one of those x plus 1s, which was the whole reason why we were getting that 0 on the denominator. So now that that issue has been worked out, we can now directly evaluate by plugging in a -1. So that's -1 times -1 plus 1 over -1 cubed plus 2. And that's -1 times 0 is 0 over -1 plus 2 is 1. So your overall limit is 0. This is a different one. Direct evaluation obviously doesn't work. We get 0 over 0, indeterminate case, so manipulation is required. This is where that skill of rationalizing a numerator that we learned in PreCalc is going to be useful. So if we rationalize this numerator by multiplying by the conjugate, root 16 plus x plus 4, root 16 plus x plus 4, and we go through and we distribute, we get 16 plus x. It's the conjugate, so the outer and the inner are going to cancel, and then -4 times +4 is -16. On our denominator, we get x, and then I'm not going to distribute on the denominator. You'll see why in a second. So the 16 minus the 16 cancel, and then you have x over x times this, and your x's cancel. So this all reduces down to 1 over root 16 plus x plus 4. So I've manipulated this x out of the denominator, and that's what was causing the 0. So now if I plug in 0, it's going to be 1 over root 16 plus 0 plus 4, which becomes 1 over Square root of 16 is 4. 4 plus 4 is 8. There's your answer. And then lastly, we have a fractional situation. You plug in 3, you're going to get 1/3 minus 1/3, 0 over 3 minus 3 is 0. 0 over 0, indeterminate. Try to manipulate. So with this, we could clear the fractions. So the least common denominator of the denominators within the fraction would be 3x. So if we multiply by 3x and 3x, up top when we distribute, we're going to get 3 minus x, and on the denominator we're just going to have 3x and x minus 3. What's nice about that is that this and this don't cancel, but sort of. They make -1. Remember, 3 minus x and x minus 3. So we get -1 over 3x once we manipulate, and now we can directly evaluate and plug in that 3. So your answer would be -1/9. So there's 2 on the bottom for you guys to try on your own and discuss and all agree on what the limit would be in each of those cases. And then your homework is on page 1027, numbers 1 through 41 odd.